I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this YouTube channel, I am providing a detailed how-to guide on using TikZ and PGF plots. I'm a longtime user of these tools, so I understand your frustrations. We're working our way through the contents of my book, Unlocking LaTeX Graphics, linked in the show notes, as well as some bonus materials. If you like this channel, please subscribe, post questions, and share with your friends and colleagues. Today's topic is TikZ node sizing. I cover how to control the spacing between the text and the edge of the node using the inner separation commands. I explain the subtle difference between font and node font in terms of that spacing. I describe how to influence the node size with minimum size, minimum width, and minimum height. I'm assuming you're already a little bit familiar with TikZ nodes. If not, go back and watch my prior videos linked in the show notes. As usual, we will create our LaTeX document at overleaf.com, clicking New Project, Blank Project. Then our project name today is Node Sizing and TikZ LaTeX Graphics. We'll get organized a bit by closing this left-hand navigation bar and increasing our size to 150%. We'll go ahead and paste in the packages that we need. Of course, we need TikZ as always, and we don't need any special TikZ libraries today. Parskip and full page are just to make things look nice, and hyperref is so that I can link the author name back to the YouTube homepage. Let's talk about the separation between the text and the node edge. Before we dive in, I'm going to go ahead and change the default node style. To do this, I use TikZ set and every node /dot style. I set the fill of the node to be yellow at 50% and the text to be colored blue. We discussed TikZ set and every node in prior videos linked in the show notes. Now we compile this first image and we have a node with a yellow background and blue text. We can see that the node has a bit of extra space around the text. Specifically, the default amount of text is 0.333 em in both the horizontal and vertical directions. The special distance em is equal to the width of the letter M in the default font. Therefore, the default spacing of 0.333 em is 1/3 of the width of the letter M in the default font. If we want more space, we can change the inner sep. For example, we can change it to be 1 em as I show in the example here. We can see the effect in this image over on the right. Specifying inner sep equals 1 em changes both the horizontal and vertical distances. We can do this separately using inner xsep and inner ysep to control for horizontal and vertical separation respectively. So setting both to be 1 em gives us the exact same image as we saw before. I can also go ahead and change them so that one is different. For example, if I set inner xsep to be 3 em, now we see that it has a wider margin in the horizontal direction than in the vertical direction. We can also change the inner sep to be 0 em. So we can have no extra space around the text. We see the result here. The node is tight up against the text, just the exact size that is needed to fit the text. If we set just one of inner xsep or inner ysep, then the other one goes to the default. So let's see what happens with these two images here. So if we just change inner xsep, we see the result over on the right. The ysep is the default. Likewise, if we just change the inner ysep, as we do here, the inner xsep is the default. There's some subtlety of how the inner sep works. It defaults to a measure based on em, which in turn depends on the default font size. So here's an example of what happens by default. If we change the font using an optional font argument to the node, as we show here, what you see when we compile this is that the spacing actually has not changed from when we were just using the regular font. Now there's a trick. If we change the font using instead the key node font, as we show here, when we compile this, then the em measure is with respect to the huge font rather than the default font, and you see a difference in the spacing. This is a subtle difference, but it can be helpful to understand when you're messing around with these distances. Of course, if you use an absolute distance, such as pt for point or mm for millimeters, then there's no difference between node font and font in terms of this kind of spacing. The size of a node is controlled by a combination of its content and the inner separations. As a result, the default width of a node is the width of its text plus 2 times inner xsep. Likewise, the default height of a node is the height of its text plus 2 times inner ysep. So let me just show an example here of just a regular node. Now we can change that width by changing the minimum width and minimum height. So we cannot make it smaller, but we can make it larger. So for example, if I set the minimum width to be 1 inch and the minimum height to be 0.5 inches, then we get the node that you see here, which has that specified height and width. A shortcut to set both the minimum width and minimum height is just to use minimum size. So here we have an example where we set the node's minimum size to be 1 inch. I want to stress that these keys specify minimum width and minimum height. How do we set a maximum width or maximum height? In general, a node will expand to fit the width and height of its contents. We can control the width by specifying text width, in which case the node width will default to the text width plus 2 times the inner xsep. We covered the key text width in a prior video linked in the show notes. In this example, the minimum height being 0.5 centimeters has no effect because the node is taller than that. If a minimum width is larger than the text width plus 2 times the inner xsep, the text block is centered in the node, even though in this case we have text that is left aligned. We see the impact here. If we don't specify the text width, then the minimum height will be the height so long as it is larger than the text height plus 2 times inner ysep. Note that the text height depends on not just the font, but also exactly which letters are included. Some letters are taller and some extend down. We see that in this current example that I'm about to paste here, the minimum width has no effect because the example is wider than 1.25 inches. What happens with an empty node? It turns out that an empty node has area thanks to ysep. So let's take a look at this here. Here's an example node. It has nothing inside of it, but yet there's still a little bit of space here. That's thanks to ysep and actually minimum size as well. If we set both ysep and minimum size to 0, as we do here, the node then disappears. There should be a node here, but it's not there because both ysep and minimum size are 0. Turns out the default minimum size, by the way, is 1 pt, so it makes a tiny, tiny little node if you don't set it to 0. Empty nodes provide an alternative way to create a rectangle of a specific size. In this example here, we have an empty node with a minimum size of 2 centimeters, yielding a 2 centimeter by 2 centimeter rectangle over here on the right. We could alternatively specify a different height and width, setting the minimum width to be here 3 centimeters and the minimum height to be 1 centimeters, in which case we get the example over here on the right. I hope you enjoyed today's video. We discussed ysep to control the space between the text and the edge of the node, as well as the subtlety of font versus node font in controlling the spacing, along with lengths that depend on the size of the font. We also covered how minimum size, minimum width, and minimum height influence the size of the node, but it may not be the final size because it depends on the node contents. This is the third video in a sequence of videos on nodes, so be on the lookout for the next in the sequence. There's a link to the Overleaf document we created today in the show notes. Please click like or subscribe if you want more videos like this. You can also buy my book, Unlocking LaTeX Graphics, at your favorite book retailer. Thanks for watching.